We are going to do a quick little lesson on heat flow. This is objective 2 in our first unit here. You should be able to define heat by the time we get done with this lesson and through the various activities in class. And you should also be able to explain heat flow in terms of different materials with a system and how energy is moving between them. So heat is that transfer of thermal energy, which remember thermal energy is kinetic energy. This transfer occurs because of a temperature difference between two or more materials. So for heat, Q is our symbol that we use for heat that you'll be seeing. The unit that we use in Regents chemistry for this is going to be in joules. And you'll see various units in some of the other activities we'll be doing. So heat and temperatures, remember, are not the same. Temperature we've already talked about. We have, just move this down a little bit. Temperature is a measure of average kinetic energy, which we've done in the previous lesson. So sample size doesn't matter in that case. If you have a temperature of 50 milliliters or 100 milliliters of water, if they're both 20 degrees Celsius, they have the same temperature. Heat, though, is the total amount of kinetic energy. So the sample size does affect that. So when we go to do calculations with heat, you'll be seeing mass being inputted because that's going to have an effect on that total amount of heat. Now, heat flow is, again, this movement of thermal energy. So thermal energy is always going to travel from a hotter object to a colder object. So one with a higher temperature to a colder object, which we would be looking at in terms of a lower temperature. So I usually tell students it's always going to move from where it's hot to where it's not. Okay, coldness does not travel. Okay, only that loss of energy that we're going to be discussing. So just kind of keep that in mind as well. So over on the left-hand side, you'll see that this is representing an exothermic process. And when you see exothermic, think of the word exit. So energy is going to exit the system. And the system is whatever our focus is, whatever we're studying. So in this process, the system has to be at a higher temperature than the surroundings. Now, the surroundings could be air, it could be other materials that are around that around that system. So if I have a cup of coffee in the morning, and this is hot coffee, and I go, to hold it, so my hand is holding the cup. The coffee is at a higher temperature than my hand, so energy moves from the coffee to the mug to my hand. So that would be this idea of a system. In this case, it's the coffee or the mug itself that's my system, and then the surroundings would be my hand or the air that also surrounds it. So the idea is that it's always going to move from a higher to a lower temperature. So in this case, it would move from the system would go from the system to the surrounding, I should say the heat. So that would be an example of an exothermic process. In an endothermic process, think of energy going into the system. So this would be if you have, say, would be like a foot, okay, and you get injured and you got to put an ice pack on it. So this would be an ice pack, and this would be your foot. Okay, if we place this ice pack on there, it's not that the ice pack is giving off coldness, it's that energy is going to move from your foot into the ice pack. It's taking energy away from you. Okay, that means that that's the endothermic process. Energy is going into the ice pack, and then because your foot has less energy, it feels colder. And is colder because it's lost that energy. So for your endothermic process, your system has to be at a lower temperature. The surroundings are at a higher temperature, so that energy is moving from higher to lower. Okay, so understanding that difference of, first off, thermal energy is always going to go from the hotter to the colder material, and then this difference between an exothermic process versus an endothermic process. Now, just realize that if you have these two materials, you will achieve like a thermal equilibrium, okay, where the two materials will arrive at the same temperature between the two. Okay, and we'll get into calculations of how we can determine what that temperature will be. But if you have two objects, say one is at 20 degrees Celsius, and you put that in contact with one that is at 50 degrees Celsius, Okay, energy is going to move from the object at 50 to the object at 20 until they are somewhere between those two and they have equivalent temperatures. Okay, and again, we'll get into calculations a little bit later on that. All right, very last part is just a way to kind of picture heat flow and allow you to answer questions when you have more than one material. So in the lab, where air temperature is 22 degrees Celsius, okay, you have a steel cylinder that's submerged into water. The steel cylinder starts off at 100 degrees Celsius and the water's at 40. I like to write these out with their different temperatures, especially if it's a multiple choice question. So that way you can figure out and go through your options more clearly. But remember, it's always going to move from hot to not. So energy is going to move from steel to air. It's also going to move from the steel to the water. And then lastly, there is a transfer of energy from the water, which is at a higher temperature, to the air. Okay, so again, focusing in on where I have my higher temperatures versus my lower temperatures and identifying where that heat flow is. Okay, so that's it for today. You just have to be able to explain heat flow, and then be able to really answer questions really well about how energy is moving between a system and its surroundings or just different types of materials.